Hello friends, I welcome you all to my channel. Today now let us discuss a topic that is structure of amines. What is the geometry or shape or structure of the amines? So friends, as we all know, जैसा कि हम सभी लोग जानते हैं that amines are derivatives of ammonia, that is NH3. So since amines are derivatives of ammonia, as they are formed by replacing hydrogens of ammonia by alkyl groups in this manner, that if one of the hydrogens is replaced by alkyl group, we get primary amine. If two of the hydrogens will be replaced by two alkyl groups, then we will get secondary amine. And if all the three hydrogens are replaced by alkyl groups, then we will get tertiary amine. Now if we consider the structure of NH3, so since amines are the derivatives of NH3, so their structure must resemble with the structure of NH3. जितने भी अमीन्स बनते हैं वो सभी अमोनिया के डेरिवेटिव्स हैं, तो इनकी ज्यामिति या इनका शेप NH3 के साथ मिलता जुलता होना चाहिए. तो लेट्स फर्स्ट ऑफ ऑल वी विल डिस्कस द शेप ऑफ NH3. इन NH3 nitrogen atom is in sp3 hybridization. The nitrogen atom in ammonia is sp3 hybridization. Similarly, like in CH4, the carbon is in sp3 hybridization, and for sp3 hybridization the expected shape is tetrahedral. So when there is sp3 hybridization, the predicted or expected shape is tetrahedral. The geometry of the molecule having sp3 hybridization must be tetrahedral, as found in case of methane. We can see the geometry is somewhat like this. So this type of tetrahedral shape is found in CH4, where carbon is in sp3 hybridization. Similarly, in case of ammonia, where nitrogen is also in sp3 hybridization, the shape must be tetrahedral, but it is actually not. The shape of ammonia is pyramidal. Means it acquires the shape of a pyramid. A pyramid like shape is called pyramidal shape. And why it is so? So if we see, then in nitrogen the outermost shell has 5 electrons, 2 electrons in 2s and 3 electrons in 2p, and all these 4 orbitals undergo hybridization to form a set of orbitals of equal energy, and that is called as sp3 hybridization. So in case of methane, if we see, then all the 4 sp3 hybrid orbitals are forming bond with hydrogen. In methane, all the 4 sp3 hybrid orbitals are forming bond with hydrogen. Whereas in case of ammonia, there is a lone pair. There is a lone pair present on nitrogen. Or there will be 4 sp3 hybrid orbitals, but one hybrid orbital will be occupied by the lone pair of electrons present at nitrogen. So in ammonia, one of the sp3 hybrid orbital will be occupied by the lone pair of electron, and actually it will not form any bond like this. So one of the orbitals in ammonia will not form any bond. So one orbital here, lone pair will be present, and 3 orbitals make bond with hydrogen atom, and somewhat they will form a distorted tetrahedral structure, simply just like a pyramid. So the structure is called as pyramidal. So this will be the structure of the ammonia molecule. In methane, the bond angle is 109 degree 28 minutes, whereas in ammonia, bond angle will be 107 degree. Means this bond will be 107 degree, slightly less than the bond length or bond angle found in tetrahedral case, that is 109 degree 28 minutes, and this is due to the repulsion between bond pair, lone pair, bond pair, and lone pair, as we have studied in VSEPR theory. So since lone pair bond pair repulsion is greater than bond pair repulsion, so this will get distorted and the bond angle will decrease to 107 degree due to the repulsion between lone pair and bond pair. And since amines are derivatives of ammonia, so they will have pyramidal structures. Similar to the ammonia here, and there will be a lone pair and R and H and H. This is primary amine. This is secondary amine, and similarly, if 3 alkyl groups are attached at nitrogen, this is tertiary amine. So the amines will also have pyramidal structure or pyramidal geometry. They will have a shape like pyramids. Now one thing happens here, that bond angle in amines will be slightly increasing. Bond angles in amine show slight increase. Means in ammonia bond angle is 107 degree. In amines it will be slightly greater than ammonia. Bond angles in amine show slight increase as compared to bond angle found in ammonia, and this is because of the presence of these alkyl groups. This is because of the presence of these alkyl groups which are larger in size as compared to hydrogen, so they will produce hindrance to each other and slightly the bond angle increases as alkyl groups are bulky in nature or larger in comparison to the hydrogen atoms. So a slight increase in bond angle will be shown in case of amines due to the presence of bulky alkyl groups at nitrogen. This is due to presence of bulky alkyl groups at nitrogen. Somehow in tertiary amines, the bond angle is about 108 degree. So there is not too much increase, a slight increase is there, and this is due to the presence of bulky alkyl group which produce steric hindrance to each other, and that's why the bond angle increases a little bit. That's all about the structure of the amines. Since amines are the derivatives of ammonia, so they will have a structure similar to ammonia, and that is pyramidal. So amines will be pyramidal in shape. In ammonia the bond angle is 107 degree. Okay, this is a distortion to the bond angle found in tetrahedral geometry, that is about 109 degree 28 minutes, and this is because of the lone pair bond pair repulsion. Since lone pair bond pair repulsion is greater than bond pair repulsion, so this bond get distorted and we can see a decrease in the bond angle. So bond angle found in ammonia is 107 degree, whereas there is a slight increase. There is a slight increase in the bond angles of the amines, and even tertiary amines have the bond angle about 108 degree. That's all for today. I hope that you might have understood the topic well. If you found the information interesting, useful, then please like and subscribe my channel for next updates on different topics of physics, chemistry and mathematics. Thanks a lot for watching my channel.